Hello everybody, this is Mr. Nardelli. Tonight I'm going to be talking to you about multiplying and dividing exponents with like bases. Our first rule, and we have it in the form of m and n, but if we have like bases, if we have x to the m power times x to the n power, we just add the exponents. A simple example, if I have x to the fifth times x to the third, I would add 5 plus 3 to give me 8, or x to the 8th power. Pretty straightforward, but if I have a negative, notice what I do here. I have to stick with my integer rules. I have 8 plus negative 5, which I really have to do 8 minus 5 to give me 3. So I get x to the 3 power. Okay, now when I divide like bases, if I have x to the m power over x to the n power, I subtract the exponents, m minus n. An example. Let me get there, we go. If I have x to the 8th over x to the 6th, I would just do 8 minus 6 to give me 2, or x to the 2 power. Okay, now if I have a negative, in this case I would have 7 minus negative 5. Don't just call that 7 minus 5. That's 7 minus negative 5, which really is 7 plus 5 to give me 12. So I have x to the 12th power. Okay, another rule we have is when we have a negative exponent. If I have x to the negative n, I can change that to a positive exponent by putting it on the other side of the fraction bar, calling it 1 over x to the n power. An example. There it is. Let me pull it up a little bit. Sorry about that. Okay, there we go. If I have 4 to the negative 3 power, I obviously can't do 4 times 4 times 4 negative 3 times. So first thing I'll do is flip it to the other side of the fraction bar, and I now have 1 over 4 to the 3 power. And then I do 4 times 4 times 4 to give me 64, but my answer is 1 over 64. Okay, let's continue on. If I have 1 over 3 to the negative 2 power, I flip it back to the other side, and this time just have 3 to the 2 power, which gives me an answer of 9. Okay, now you also will have problems such as this. Simplify x to the negative 2, y to the 2, z to the negative 2, over x to the negative 4, y to the 2, z to the 2. You can do the traditional method of subtracting. So to do my x's, I would do negative 2 minus negative 4. That can be kind of cumbersome, but there's a way to get out of it if you don't want to do the negative numbers. Simply, whatever has a negative exponent, put to the opposite side of the fraction bar. If you see a positive exponent, keep it there. So you can see my x to the negative 2 is going to go to the bottom of the fraction bar and become x to the 2. My x to the negative 4 is going to go to the top of the fraction bar and become x to the positive 4. Now, you'll see my y to the, that should be a negative, sorry. There we go, mistype. I have y to the 2 power. I'm going to keep it right where it is, right there on the top. But this y to the negative 2 power, I'm going to move it to the top of the fraction bar. Now my z to the negative 2 power drops to the bottom, and my z to the 2 power stays. And notice what I did is I kind of chunked them together so I can easily see them. So now I'm just going to go ahead and solve, but I'm using all positive numbers. It's just a little advantage. X to the 4 minus x to the 2. Well, that's just 4 minus 2 giving me x to the 2. Now my y's, since they are multiplying, I'm going to add the exponent. Y to the 2 times y to the 2 gives me y to the 4. And then on the bottom, I've got z to the 2 times z to the 2 2 plus 2 is 4, and I have my answer of x to the 2, y to the 4, z to the 4. If you need anything, email me at nardelli.efsc@gmail.com. Thanks.